All right, guys, so we are looking at different types of functions. We're going to be comparing linear functions, quadratics, and exponential functions. And the first way that we're going to look at it is in regards to the different types of forms that you might see them. When we look at something that's linear, it's going to have like y equals mx plus b. Or like slope-intercept form is what most people call it. And then you have standard form, which is like ax plus by equals c. If you ever see anything like this without an exponent in regards to x, then you know that that's going to probably be a linear function. And then if we look at quadratics, we've been talking about this a lot. This is what your standard form is of a quadratic function. And then this is considered to be your vertex form of a quadratic. If you see something along those lines, then you know it's a quadratic. And then exponential. The difference between exponential and quadratic is that with the exponential, you notice that x, or your input value, is your exponent. Anytime that you notice that, it's going to be form of an exponential function. So what you guys will do is you're going to try these, just identify what you think each of these are, and then check with me or with someone else in the room, and you could see if you got those. But then another type of form that we're going to look at is we could see it graphically. And if you guys remember with lines, well, if I look at a linear, it's going to look like a line. It could look like that. 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 Okay? Well, when we look at quadratics, I know it's a U-shaped curve like this. Well, hopefully yours is going to look a little bit better, like this, an upside down N. All right. And then when we look at exponentials, remember exponentials start growing slow, and then all of a sudden they grow really fast. Okay, or they decrease really fast, but then they even out at the end. Okay. So what you're going to do is you're going to try these three that are on your notes, and then you'll check with me, and I'll let you know how you're doing. Okay. But then the last way that we can look at it is if we look at things through tables. And we're going to talk about things for linear and quadratic in regards to their difference, or like looking at like their slopes. If I look at the slopes of a linear, their first difference are the same. So if the slope between y values is constant all the way through. If I look at a quadratic, the second difference, the first difference won't be the same, but the second difference is going to be the same. And then if I look at exponentials, none of these two things work about their differences, but they have a common ratio between the y values that you'll notice. So let's look at an example. I already found the y values. You guys could write these down. But what we want to do is just find out what the difference is between these y's. And what's happening? I'm adding 2. Negative 6 plus 2 gets me negative 4. Plus 2 gets me negative 2. Plus 2 gets me 0. Plus 2 gets me 2. Plus 2 gets me 4. Plus 2 gets me 6. So in this case, that first difference is the same. So we're going to say it's linear because our first difference or slope is the same between y values. Okay? Now if I look at this other set of points, we already know it's a quadratic, but let's look at what's happening here. Looks like right here, I'm subtracting 5. And then I'm subtracting 3. Then I'm subtracting 1. Then I'm adding 1. Then I'm going to add 3. And then I'm adding 5. So you can notice that the first difference, there's no difference whatsoever, or there's nothing similar at all between these. Well, let's look at the second difference then. What do I have to do from negative 5 to negative 3? Well, I could just add 2, and that works out. And I could add 2, and that'll work out. Add 2, add 2, add 2. So we have to just find out what these differences are of the y's, then do it again. You'll see that these are all the same. So for a quadratic, the reason why this is a quadratic is because the second difference is the same. You'll always notice that for quadratics is that their second difference is the same. Well, if I look at this next one, well, you'll start to notice something here. If I take 1/8, well, I'm adding 1/8 plus 1/4 plus 1/2 plus 1 plus 2 and plus 8. So there's no pattern whatsoever. And you guys will start to notice if I do that again, well, what am I going to be doing? I'm adding, actually, the previous value that I was adding, I'm adding again to it. So that's not going to work out. But if I look at the y values, just compare them. So if I take 1/4 over 1/8, what do I get? I get 2. If I get 1/4 or 1/2 over 1/4, that's going to be 2. If I take 1 over 1/2, that's going to be 2. Okay? 2 over 1 is 2. 4 over 2 is 2. Or 8 over 4 is 2. So the reason why this is going to be exponential is if I look at the ratio between these two y values, it is constant. The ratio between y values are the same. Okay, hopefully this helps out, guys. You're going to be working on the rest of this, and you're going to check with me in a second. But hopefully this will be a good starting point for you.